Hey everybody, let's go over lesson 1.1 on Riemann sums by starting with the definition. So, let f be defined on a closed interval a to b, and let delta be a partition of ab given by that expression, where a is the first x, b is the last x, and all of the other x's are strewn in between. So essentially we're going to slice this up into different rectangles. Notice delta x sub I is the width of the ith subinterval, and c sub I is any point in the ith subinterval. The sum from I equals 1 to n of f of c sub I times delta of x sub I is called the Riemann sum of the function f for partition delta. Now, that's a very long-winded mathematical definition. So here's what I'm going to do to try to simplify it for you. We're going to play with Legos. No, I'm not joking. I'm actually serious. We're going to play with Legos. So, here I go. I've already got a function drawn. That's going to be my function f, and it's on the interval from a to b. So what we're going to do is we're going to divide this up into different subintervals in order to approximate the area between the curve and the x-axis. So that's what I want to do, is I want to figure out an idea using simple geometry of approximately this area that's not a simple geometric figure. So here we go. All right, so let's begin. What I'm going to do is take different rectangles and try to fit them exactly on this function of f, and what I want to have happen is I want somewhere along the top of this rectangle to touch function f. Like for instance, right here, it's touching in the top left corner. All right, let's keep going and see if we can get some others. Notice here, it's touching somewhere in the middle of the rectangle, but not quite on either end. It may not be in the exact middle, but it's pretty close. As long as it touches somewhere up top, we're good to go. Let's see what else we can do. All right. All right, notice my rectangles don't have to be the same width. So this first rectangle is 2 studs wide, the big red one, and the blue one right next to it is 4 studs wide. This kind of really light gray is 2 studs wide. The almost, I'm going to say, greenish gray is only 1 stud wide. The black is 2 studs wide. This really dark, almost steel gray is 1 stud wide. And this last one that's sandy colored is 2 studs wide. So notice, the width of the rectangles don't have to be the same as long as the height of this rectangle touches the function somewhere. And I did a pretty good job of estimating that all the way across. Notice this one's on the left corner, this one's on the right corner, and most of these others are somewhere in between. And that's okay. So here's what I'm going to do. Now that I've got my rectangles, I'm going to try to estimate the area under that curve using these rectangles. So I'm going to take the width of the rectangle, which like I said for the red one is 2, and I'm going to multiply it by its height, which in this case is 1, 2, 3, 4, 5, 6, 7, 8 studs. Then I'm going to do the blue one. So 4 by 1, 2, 3, 4, 5, 6. The next one is 2 by 4. The next one is 1 by 6. Then it's 2 by 7, 1 by 8, and this last one is 2 by 1, 2, 3, 4, 5, 6. Now that I've gotten all these rectangles written down, again, width and length. So we're going to multiply them. 2 times 8 is 16, 4 times 6 is 24, 2 times 4 is 8, 1 times 6 is 6, 2 and 7 is 14, 1 and 8 is 8, 2 times 6 is 12. Then I'm going to add them all up. And that means that F, this curve, the black curve that I drew at the beginning, is approximately 88 studs of area. Now, notice this is not going to be a perfectly accurate description of the area under the curve because there's some spots where I'm a little bit under, but there's also some spots, especially with this blue one, where I'm a little bit over. So that's why it's okay. This is just going to be an approximation, and as long as I'm approximate, as long as I'm close, I'm okay. Being exact with a Riemann sum is not always going to happen. But so while I'm sitting here talking about Riemann sums, there's a couple new vocabulary words I want to go ahead and mention. For instance, one really big vocabulary word that's important right now is called the norm. The norm is the width of the widest rectangle. So take a second and look at this picture and try to figure out which one is the widest rectangle. If you said it's this blue one, you're correct. So I'm going to write the norm. It's got double brackets and delta because that's the partition. And so the widest rectangle is 4. It's got 4 studs. Another vocabulary word that's really important right now is regular. If we have a regular Riemann sum, it means all of the rectangles have the same width. You're probably thinking to yourself right now that this is not a regular Riemann sum because each of the rectangles is different sizes. So notice again, the red is 2 studs wide while the blue one is 4 studs wide. As long as they're not the same, it's not regular. All right, so hopefully you enjoyed this lesson using Legos for Riemann sums. Hopefully you'll be prepared for some examples in just a second.